Welcome to another session of GIS Networks. This is the second part of data structures. Today we are going to learn array implementation of stack. So let us begin. Let us see what is a stack. A stack is a data structure which is used to store data in a linear fashion. That is, stack is a linear data structure, sequential data structure. It is an abstract data type in which data is inserted and deleted from a single end. That is, insertion and deletion happens on the same side, on the same end. Therefore, it follows last in, first out principle. Because entry and exit is from the same side. So, the element which enters into the stack at last, that element is the one which is removed. So, that is what last in, first out, LIFO principle. Okay, so that is about stack. It is a sequential data structure and data are inserted and deleted at the same end, from the same end, and it follows last in, first out principle. This is a pictorial representation, that is, this is a stack and push is inserting the element into the stack and pop is removing an element from the stack. See, same end at the top of the stack, right? Pushing to the top, pop from the top. Okay, so that is why last in, first out. And now common stack operations. Push and pop we have just seen. That is, push is adding an element to the top of the stack and pop is removing the element from the top of the stack. Next is peek or top. Return the element at the top of the stack without removing it. That is, peek points to the top of the stack, points to the top element of the stack. Next is size. Return the number of elements in the stack, that is size. And is empty, that is whether the stack is empty or not. If the stack is empty, that is if the condition is true, if it is true, that means stack is empty. If stack is not empty, it returns the value false. Okay, so these are the common stack operations. That is, push, adding an element into the top of the stack, pop, removing the element which is at the top of the stack, peek, return the element at the top of the stack without removing it. It points, it returns, it prints the element. Okay, and next is size, returning the number of elements in the stack. What is the size of the stack? How many elements are there? Number of elements. And next is empty. That is, return true if the stack is empty, else false. So these are the common stack operations. First, let us see push operation. Push is adding an element onto the stack. We know that push and pop at the same, through the same end, right? Adding an element into the top of the stack is referred to as push operation. Adding a new element to the top of the stack, that is push. Two steps are there. Increment the variable top so that it can now refer to the next memory location. That means, if I will show you, if this is a stack and this is Now this is top. This is top of the stack. Okay. When you are entering an element, that is when a new element is pushed into the stack, what happens? Increment the variable top. That is now this will be top. Okay. That is why increment, that is top is equal to top plus 1. So that is why here increment the variable top so that it can now refer to the next memory location. This previously this was top, and now when we entered one more element, that is pushing one more element, top becomes this one, right? So that is previous top plus 1. That is what increment the variable top so that it can now refer to the next memory location. Add element at the position of incremented top. That is where now we are inserting the element at the top of the stack where t is equal to t plus 1. This is referred to as adding new element at the top of the stack. So these are the 2 points. Okay. And stack is overflown when we try to insert an element into a completely filled stack. Therefore, our main function must always avoid stack overflow condition. That is, before entering into a stack, before pushing an element into a stack, we have to check whether the stack is full or not. If the stack is full, that means the stack is in overflow condition. That is when if the stack is full and you are trying to enter and push an element into the stack means no space is there, right? So that is overflow condition. This is the algorithm. Begin. If top is equal to n, that is full, then stack is full, overflow condition. Else top is equal to top plus 1 and the new item is now top of the stack. That is, if top is equal to n, then stack is full, else top will become top plus 1 and top of the stack will be the new item. Implementation of push algorithm in C language. See, there is a function push parameters val and n. N is the size and val is the value which you are going to insert. If top is equal to n, overflow, that is no spaces there, it is full. Else top is equal to top plus 1 and the new item is now top of the stack. Okay, this is implementation of push algorithm using C language. That is, as a function, push function, and if top is equal to n means the stack is full, no spaces there, right? So if no space is there, just print overflow. Else, that is, if space is there, enter the element into the push the element into the stack. At the time, top will become top plus 1, and now at the new top you have to enter the value. Okay, so that is push algorithm in C language. Next is deletion operation, that is pop operation. Deletion of an element from the top of the stack is called pop operation. That is, insertion and deletion is happening at the same end, through the same end. Okay. Topmost element of the stack is stored in another variable and then the top is decremented by 1. In push operation, the top was incremented by 1, and when we are popping the element, that is when we are removing the element, the top is decremented by 1. The operation returns the deleted value that was stored in another variable as the result. That is the element which has been removed. It is now returned. The underflow condition. In push it was overflow, and in pop it is underflow condition. That means no element is there. It is empty. That is, if the stack is empty, it is not possible to remove an element. So the condition is underflow. The underflow condition occurs when we try to delete an element from an already empty stack. That is underflow. Okay, so this is about pop operation. Here comes the algorithm. If top is equal to 0, then stack is empty. And next is item is equal to stack of top. That is, you are returning the item which has been removed, right? So the top element is now stored in item, and top is now top minus 1. So this is the algorithm. This is the implementation using C language. Pop function, top is equal to minus 1. That is the underflow condition. It is empty. Okay. Then top is equal to minus 1. Then return 0, else you have removed the element and you are returning it, right? So that is stack top minus minus, and top is now top minus 1. So that is what implementation using C language. Next is peek operation. Peek operation involves returning the element which is present at the top of the stack without deleting it. You are not deleting the element, deleting the element at the top of the stack, but you are returning it. You are printing it. Okay, you are visiting it. Underflow condition occurs if we try to return the top element in an already empty stack. Here also underflow, because here also returning is happening, right? You are displaying it, you are printing it. So underflow condition. That is, you are checking for that also, underflow. For push, you are checking for overflow, and for pop and peek, you are checking for underflow. So this algorithm, begin, top is equal to minus 1 if, then the stack is empty, else top of the stack element is returned. This is the implementation in C language. If top is equal to minus 1, print underflow, else return the element. So it is very simple. This 3 main operations: push, pop and peek. So we have gone through what is a stack. It follows LIFO principle, last in, first out principle. Main operations: push, pop and peek. Push is inserting an element, pop is deleting an element, and peek is returning the element which is at the top of the stack without removing it. Okay, so that is about stack. Hope it was okay for you. You understood the content, what is a stack. It is an important content in data structures. So go through this. Hope it was okay. Thank you.